And then you're going to have homework of taking integrals and derivatives of inverse hyperbolics. I'm not even going to show you inverse hyperbolics, because all you'll do is you will use the definition of the derivatives of those. What I'm saying is you will write down on your card, you'll write on your card, see that red bracket right there? You'll write down sine, cosine, and tangent, the hyperbolic inverses, and you just plug them in, okay? I just don't have time, and they're not used that often. I am going to give you an example. And somebody remember to ask me on test 3 if there is a hyperbolic problem on there. There's a fair chance there won't be, because I think you'll use almost always from the table of integrals. Okay, here we go. Is this one starting off good? You ready, Ed? You're gonna be up to the plate in a minute. Anybody want to tell me what to do? You know what the integral e to the x is? You know what the integral of the hyperbolic sine is, don't you? Isn't that the integral of the hyperbolic sine, the hyperbolic cosine? Back to the way you learned to do antiderivatives. But now they're multiplied together, and neither one of those does you a whole lot of good. Would you say?
Not trying to substitute.
What?
I said not if you're going to try and integrate it the way we've been
Yeah.
learning.
But there is a way out. What is it? What do you do, Ed?
Just plug in the definition.
Yeah. There is, I don't know of a way out of that. I don't know of a way out of it. And if you do, tell me, and I'll start doing it, because I don't like what I'm about to do. But I don't know of another way to do it.
Wouldn't the integration by parts might work?
Yeah, but they don't know that.
Oh, okay.
Yes, I do integration by parts and twice and live happily ever after. That's exactly what I do. But they don't know that yet.
Right.
They're about to know it, but they don't know it yet. You follow? There's no way out. So what I'm saying is, I've got that E out there, and if I go back to the E's from the definition, at least I'll have all E's. And then I might get lucky. Remember, I believe in getting lucky. That's one of the best methods to integrate, and it certainly is the best method for differential equations, is get lucky. So I think this is 4 times the integral of e to the x times Isn't that what you think?
E to the minus x.
Yes. Thank you. Which I think is 2 times the integral of e to the 2x dx minus the integral of minus the integral of something dx. Don't answer out loud. Not just something, but something really nice.
I can't teach, but. Okay, yeah, that makes sense.
E to the x times e to the x, that you add them, so that's e to the 2x. E to the x times e to the minus x, you add them, x minus x is 0. Any number including 2.72 to the 0 power is 1. We'll do it like we always do. I'll take one and you take one. I'll take the one on the right. What needs to be right where my finger is for us to live happily ever after?
X squared, or no,
Come on.
C?
Who said it? I'm going to run out of gold stars today. If I had this 2 right there, wouldn't I have u, wouldn't I have e to the u du right there?
Yeah.
Everybody agree? Everybody? I'm trying to teach you to learn how on real simple integrals, nothing hard, because on the ones that are the least bit tedious, I still say let u be equal and do it the long way. And I expect you to do it too. But on ones where you know that you need to have the derivative of the angle out there, if you know that it's just 2, then you don't always have to write let u be equal. Follow? And I want you to try to get comfortable with that. If you are not comfortable with that, all you would do is what we've done from day one, right? Let u be equal to 2x, huh? And work it out just like you always have. So don't let me mess you up. If you see what I'm doing, do it. If you don't see and are not comfortable with it, remember in one of my 5 rules is let u be what the exponent is. So wouldn't u be 2x?
Would it be
let's do it. Let's do it. I'd say let u be equal to 2x, du is equal to 2 dx, or dx is equal to 1/2 du. So then this integral becomes 2 times the integral of e to the u times 1/2 du. And then these two go away. Follow? So all I'm telling you, do not hesitate to do this. Don't take any chances unless you're really comfortable with it. Okay? And then that means that this is equal to 2e to the u minus u. Am I right? Now, Frank, I'm worried about this one on the left. I need to think about that. I think this is like that. I think when you make this substitution, all you have left is the integral of e to the u du, right? And this 2 was in front of it, so it's gone. But I still have this 2 times this integral, huh?
Right.
Okay. So now I have e to the 2x minus 4 e to the x and that's it. And then I'm going to call this I. So now I is equal to e to the 2x minus 4e to the x, evaluated from log 2 to 0. Isn't this my old trick of getting rid of the limits of integration and then go through and integrate it, and then at the very end put the limits back in? Isn't that my old trick? And it cuts out a lot of writing and opportunities for mistakes.
I'm a little confused as to where you got 4e there.
I think that u is equal to 2x.
Right.
So 2 times 2x is
4x.
4x. Thank you. Thank you. Thank you. If you remember, I stood there and looked at it a minute after I wrote it because it wasn't that it didn't look right, it just didn't feel right for some reason. Thank you. Everybody okay with that?
So why is it, maybe I'll finish something, why is it that you can just substitute u in for the other integral? Like with the 1, why can you just throw that u into that separate integral?
And you know, actually, Daniel, that is a terrific question. Daniel caught me. I changed this integral to u's, didn't I? Right? This one one, I never changed the U's, right?
Yeah.
So shouldn't that just be 2 times the integral of 1, right? Everybody agree?
Yeah.
And the integral of 1 is
X.
x. That get it?
Yeah, and when you, so you can write e to the u minus 2x, or right after the equal sign to your integrals. How would you, because you'd write using
Daniel,
x's.
you know what, I just have to,
You'd write using x's in the same,
I'd have to just write it.
okay.
And remember my rule about not having U's and X's in the same one?
That's, yeah.
I guess if you wanted to live with that rule, you'd just go ahead and change the U at the same time.
It'd be 2x, because you're bringing the 2 from the original.
Sure would. But other than that, everybody understand why there's 2? Okay? Now I have e to the 2 times e to the log 2 minus 2 log 2 minus e to the 0 plus 2 times 0.
E to 2, e to the log 2. Would you just do it e?
If you have 3 to the 5th times 3 to the 4th, isn't that 3 to the 5 times 4? And I'll now do it in reverse. This is e to the 2 times x. So that would mean I just multiply. Everybody okay with that? Okay? But, right? So isn't this, and this is what? 1. And this is 0. So now my answer, e to the 2 log 2, whoops, log 2,
Should it just be 2?
Yeah, it's just 2.
nope. Does that look right to you? This is just a 2, isn't it? Right? So 2 times e to the 2, isn't that what I've got here? Right? And then minus 2 log 2, that's about as good as I can hope for. I could call it log 4, but I don't know if that's any better. And then I remembered to tack this negative 1 on. And obviously, I'm at the end of the page, but I'd probably write one more step and put the 2 out front. But again, that's just eyewash.
In the homework, sometimes you get a lot of eyewash. Like, they might not take 2 into, they're gonna
I know.
take 4, you know.
I know. And if that happens to you, just do a screenshot of that, or take your cell phone and take a picture of it and email it to me, and you don't even have, and I'll just go through and give you credit. But you got to tell me You gotta show me what your answer was, and then show me what the right answer was. But I'll just give you credit, I don't even want you to rework another problem like it for that.
And of course, Compass would have you type in something like 2 times
I know.
e squared minus log of 2 minus a
I
half.
know, how do I say this and not sound bad? I think I'll say it like this. Sometimes some of these people that design the software have not had a lot of math from Cal 2 on.
You don't actually need anything after algebra.
And my point is that they are stuck in leaving the answer pretty kind of ways, when in calculus, that's the last thing we would care about, is making something look pretty. We'd want it to be in a useful form. And that's why I'm saying I don't want to waste not a second of your time with that. So if it happens, just take a picture of it and send it to me. Questions? Okay, there's hyperbolic functions. The inverse functions you're going to have to do on your own, but I'm telling you, it's plugging numbers into a formula that you're going to write down. Don't put any of this on your card until I tell you whether I'm going to put a hyperbolic on the test or not. Question? Now, let's understand again about the hyperbolics on the test. The reason I'm not going to do that is you're going to have a test using the table of integrals, and the hyperbolics are in that table of integrals. So, I may or may not decide to test you. If I do, I'll tell you what to put on the card. I am going to have a hyperbolic on that table of integrals test, so I can make sure you know how to use it. Okay? All right. See you Wednesday. I'll be here this afternoon if you need me. I'm going to go about noon, get a Subway sandwich, and I'll be in my office a lot of the afternoon if you need me. Nicholas, are you getting out?
Yes.
You are. What are you going to do? And what are you going to be an engineer? Did you get into School of the Mines?
No,